This episode is brought to you by Squarespace.
Alright, hey everyone, this is Nathan Builds Robots. We're going to take a look at the K2 today, but instead of running prints, we're going to take a look at all of the enabling technology behind this printer being one of the largest and fastest 3D printers that I've owned. And yeah, there's a lot of crazy stuff here, so if you're into nerdy details, I think you'll love this video. However, if you have touched grass in the last 24 hours, this video might not be for you. But without further ado, let's get into what makes the K2 Plus so strange and special. So I'm going to power this thing up. You can see the lights up top turn on. There's one light up there and another light up here to help you get even lighting in the whole printed workspace. We've got a screen here that tips up and down a little bit. It can't tip down too much further, otherwise it would interfere with the door here. It's pretty close there, but there's enough room where it's not going to cause any issues. So this is going to be great if you have this mounted up high, then you can tip the screen a little bit down. However, if this thing's mounted on the floor and it's pretty far below you, just tipping the screen up will allow you to touch the screen more easily and operate this machine. Now let's take a look at the Hotend. Some people complained that the nozzle isn't going to be compatible with the previous Creality nozzles. It looks pretty similar to all the other stuff that you have on the Creality K1, but this has just got like an extra centimeter or so of melt zone, which is just going to help you get higher flow rates. So you can see that just screws in right there, and you've just got a cylindrical ceramic heater there. Excuse the noise, that's the CFS system starting up. I just turned the machine on, so it's just checking all the filaments and making sure that I didn't change filaments over while the machine was turned off. What it's doing here is it's just test feeding all of the filaments, and it's also reading these little codes here. This thing has a bunch of RFID readers in it, and it can identify what type of filament is loaded up into the machine. And all these Creality spools of filament have an RFID chip embedded in both sides, so that no matter how you load it up, it should be able to read it and identify what's loaded into the printer. It did have an RFID failure to read on this one, and so let's just refresh that and see if it can figure out what's loaded. And also it knows the status of the spools. So you can see these two spools on the right are just about empty, and on the little display here they look like they're just about empty. This black one is about half full, and yeah, that reflects the size of the spool there. Alright, and after clicking refresh on that spool, it figured out that the white filament was loaded in there. So you can see there's a little bit less white filament than the black filament, and it knows that. So that's pretty cool. It's got some sort of filament monitoring, so it knows when you run out. Here you can see the spool holder. It doesn't know what type of filament is loaded up in it because there's no spool over here. But I imagine you could use this RFID reader to detect what type of filament is loaded there. And maybe you could get a fifth spool of filament if you attached some kind of motorized spool holder onto the side here and allowed it to be able to feed and retract, but it doesn't have that capability right now. Maybe that's something they could add in the future. You can edit these filaments, so let's say it couldn't read the spool for some reason, or you're using a third-party spool. You could select the brand and name and assign a color and type of, and material type. They've redesigned the extruder. I have the old extruder here because I just have all sorts of stuff for reference. So here's the old K1 extruder design. I wasn't a big fan of this. I actually tore this apart on camera, both figuratively and literally, just taking a look at the internal components. I really didn't like it because these drive gears are only supported on one side. We call that cantilevered in mechanical engineering. So really you want a doubly supported shaft where it's got a ball bearing on both sides of the gear. And that's just going to give you much better performance, both structurally and, you know, it'll be able to push with a lot more force and be more accurate. And fortunately on this design, apparently it's been redesigned such that the extruder has double bearings. So it's got bearings on both sides of the drive gears. I haven't taken this apart and verified that myself, but I trust whoever said that on the internet. Then we've got a fan up top. The main part cooling fan is around back. I can't see what you guys are seeing right here, but I think there's got to be some kind of part cooling fan back here. Yeah, that's it right there. And it's directed out these little ducts right here, so just two little holes. And this is a pretty tough little duct here. just because it's bolted down really well. You can see I can yank on this, and it's really quite sturdy on there, so I wouldn't expect that to break off during a collision with a part if that were to happen. So let's say you had to do a complete hot end swap and remove the heating element and the thermistor and just replace everything down here. You can just unplug these now. On the older version, they were using glue to hold these in place on the K1. This time they're using proper connectors, and they were using these type of connectors on the Ender 3 V3. So yeah, that's just, I think, a rolling update in Creality that they're going to stop using glue on things that need to be serviced like that. This extruder, apparently you can remove it. I'm not going to remove it in this video just because there's a lot of stuff to look at on this machine, so we got to keep moving. And we've got a little fan right here to blow air across this heatsink, which helps you make sure your heat break works properly. Maybe we could do a hot end teardown in another video, but this is what we can see right now. It's designed really nicely. It's got a linear rail here, so this is like really solid and will allow you to print at high speeds. Also, just moving this back and forth, I can feel that this assembly is very light. Like, I can move this back and forth very easily. So they're using some kind of metal tubing. I'm not sure if this is metal or steel, so we're gonna stick our little guy to it. Yeah, that's aluminum, not steel. And then this top rail, obviously that's steel because that's just how those are made. So yeah, there's a lot going on up there. There's a little breakout board. It's also got a little filament cutting mechanism up here. I'll give you a little look on this side. Not really sure what I'm looking at, but when it moves over to this end, it bumps into this little nub, and that pushes on a little razor blade that cuts the filament. Very similar to the Bamboo Lab system, where they have a filament cutter above the heatsink. Then over here on the sides, we've got these steel rods. They're very rigidly held in place because they're attached to a metal frame on the top and bottom. So they're really held in place quite well. There's no fasteners there, but that's probably just a press fit or something. When it comes to part cooling, we've got two really large blower fans that blow air right up at the level that the printing is happening at. We've got one on both sides. Really powerful part cooling, because when you're printing at high speeds, that becomes a necessity.
If making a website at high speeds is a necessity for your hobby or small business, then Squarespace is a perfect solution for you. All you have to do is go to squarespace.com/NathanBuildsRobots and you can get started right away. They're constantly adding new tools to speed up your web design workflow. You can choose to use any of their professionally designed templates, or you can build your own with AI. So here it's just going to generate the website for me, and there you go. And if you want, you can even use AI to generate a good title for you. So we're just going to go ahead and try asking it to write. Ah, yes, this is good. Revolutionize your creations with quadrupole. I don't think it wanted to say quadrupolar because, you know, that's not a real word, but every once in a while you need to help AI out a little bit. So if you want to start your free trial of Squarespace, head to squarespace.com/NathanBuildsRobots. You get a 2-week free trial. And then if you like the website you've designed, you can go ahead and get a subscription started and publish it, and you'll have your very own website on the internet. So thanks to Squarespace for sponsoring this episode. Now let's get back to looking at the K2 Plus.
Around back, you've got this chute. That's where your filament purging goes into. And it's got this little scrubber brush right here and some kind of little metal spatula that I guess this is more wear-proof. And then it's got the little whacking stick that it poops into and then drops it into the chute. Up top, the cable chain management is all very good, especially compared to previous versions of the K1. Those basically didn't have enough room to fit all of this cable chain. In this one, they've definitely got enough room, so even if you're all the way up at the side here, it runs very smoothly. And they've got this slick area up here. I don't know if it's a sticker or what they put in this place. I'm guessing this is some kind of Teflon tape to help this slide more easily. If you zoom in right here, you can see a little load cell, this hot end. Don't touch this when it's hot, but there's a little load cell right up there. White glue stuff is typical for what you see on load cells. That's what it's going to be using for bed leveling and mesh calibration. So you're probably not going to have load cells underneath the print bed like you did on the K1 and the Bamboo Lab printers. You just got the load cell baked into the print head there. There's your little thermistor for temperature monitoring of the print chamber, and it's got an active heater right here, which we'll take a look at in a little bit. We'll be able to get a better view of this. But basically that's just a heating element that sucks air in from the outside and blows it in all heated up. These are two exhaust fans with little charcoal filters built into them. I'd prefer HEPA filters to filter out any particles that are being generated in the print chamber. These type of charcoal filters aren't going to do a whole lot, but maybe you could find replacements for these that are HEPA filters. This tape left a little residue, but with some isopropyl alcohol I could rub that off if I wanted to. Here's the cable chain that's coming around from the back, so that gives you a hint as to where the electronics are in this machine. It's not inside of the chamber here, it's probably around back, so we'll take a look at that in just a minute. These panels on the outside, these do not have any exposed fasteners, so this is probably glued in place. What I'm thinking is this is a right side frame that has, you know, this whole, this beam, and some structure, internal structure behind this that's all attached to this. This is the frame from the outside. It's all one piece of aluminum, including all this down here, and all this up here, and all this back, you know, all of this. This is all one piece, and then this panel is bonded to it. So yeah, you're not going to be able to just unscrew some pieces and remove that. It's just glued in place. But I don't think you're going to have to remove that to get access to any of the important electronics. Let's play around with the temperatures. It says the nozzle can go up to 350 degrees. That's pretty crazy. The print bed can go up to 120, and the heated chamber can go up to 60 degrees, which is pretty good. Now, if you want a really high temperature printer, like industrial machines will go up to 80 to 90 to 100. You know, they're going to be a little bit hotter than this, but 60 degrees is very good for your basic entry-level high-end filaments. So I'll just press Home Z. All right, the print head is moving, and right now this decorative cover is removed. This is like a decorative and protective cover, so we can see some more stuff on the print head. But we're just going to leave that off for now. Now watch this Z-axis. All right, watch this Z-axis. Right now it's homing itself at the bottom of the machine. And there's a couple sensors that I'll show you in just a minute here. But then it moves up to the top. And these Z-axes, this Z-axis is moving faster than I've seen on any of my other printers. It's about twice as fast as what I'm used to. So it's got a really speedy Z-axis, and that's going to help you basically do Z-hops faster, and these type of homing maneuvers will take less time. Now, when you're homing at the bottom of the machine, there's these little metal tabs sticking off the bottom, and those are poking down into these holes, and there's some little optical sensors down there. And it's got one of those on each side. Do not leave objects inside the heated, under here basically. You're just not going to want to leave stuff here because when the bed comes down, it might run into these. So, you know, heed that advice, just don't leave stuff down there. When you turn the machine off, the bed does sink down to the bottom, and that's because they've got some smooth running bearings there. You got enough mechanical advantage to backdrive those motors and have it sit all the way down when you turn the machine off. That's not necessarily a good or bad thing, but it does mean if you leave something like sitting down here and the hot bed is still hot and you turn the machine off, then it could sit down on it and squish it and melt it. Let's say you're printing some polycarbonate or something, and you've got the heated bed all the way up to 120 degrees, and then it sits down on top of your PLA parts that you had randomly sitting down there when you shouldn't have, then that might cause an issue. So yeah, don't leave your stuff down there. They got a nice little warning here to tell you not to do that, so don't do it. This plate at the bottom is covering up some really important electronics in this machine, so let's go ahead and pop this off. I undid all the screws already. These screws had to be undone by cutting away a little bit of this sealing tape. So I just, sliced it right there and there and unscrewed it. There's 3 screws in the front and then about 10 screws around the perimeter. And once you undo those, you can take a look at the important electronics down here. This was my first attempt at finding the electronics, and it was, I didn't find them. As you can see, there's no electronics down in the bottom of the machine. However, if you're a modder and you like modding things, you might have some extra electronics, or maybe you want to install a chamber heater down here or add some additional motors or something. You've got a lot of space to work with down here. You might even be able to store some filament down here. I'm curious to see if anyone ends up utilizing this space underneath the bottom of the machine. And again, you can see some more of this aluminum die-cast construction. This thing is absolutely beefy. I think this rod is just press fit into place. Pretty crazy. And then you've got these kind of more substantial hinges, and they're bonded to the glass here. So if you wanted to remove that glass and replace it with something else, that would be kind of tricky. You've got these motors. I think these are the same type of motors that are used on the X and Y system. So these will be your FOC closed loop motors. I call them servo motors because any type of closed loop motor is technically a servo motor by definition. So yeah, pretty cool stuff there. Am I missing something in the definition of a servo? And then I also found that there's a couple electronics boards up here. I assume these are in a position to be able to get and receive Wi-Fi signals. This RFID chip reader and this USB drive port is, on the back side of one of these boards. I think this is the Raspberry Pi equivalent. And over here, I'm not sure what that is either, but maybe someone a little smarter than me knows what these things are or what they do. We'll take a look at this one as well. Anybody know what that does? I sure don't. So if you know, let me know in the comments below. Now you might be thinking, isn't this in the heated chamber? Isn't that going to cause an issue with the electronics? It might, maybe. 60 degrees isn't that hot, so maybe it'll be fine. And tool heads are always in the heated chamber, so the PCBs on this thing can survive 60 degrees, then you can design other PCBs to survive 60 degrees. It's not like this thing's going up to 80 or 100 degrees where you would really want to get the electronics out of there. These are kind of insulated in their own top little corner. There's a black plastic cover that goes over the top of this. And if it was an issue, then you might be able to add some vent holes up here and cool those circuits off. But in the test that I've done so far, it hasn't been an issue. That'll be something to keep an eye on though. It looks like there's one last PCB back there. Not sure what that is. Yeah, lots of stuff going on. And I thought I saw all those and I was like, wow, there's all the electronics in the machine. But I was wrong. There's even more. So take a look back here. I took the back panel off, and there's a lot more electronics on this machine, and a lot more crazy stuff that I wasn't expecting. So this is your typical 350 watt Ender 3 power supply. All this stuff on the back is outside of the heated chamber, so that's going to be good for keeping the electronics cool. This fan is pretty quiet for a power supply fan. It's running right now, and it's not really making all that much noise. So it appears they've upgraded to some higher spec fans that make less noise. Then you've got this board, which looks like some sort of breakout board that has all the stepper drivers, but I don't really see any stepper drivers on here, which is kind of confusing. And then over here, you've got this acrylic cover on there. Usually when you see that, that means you're dealing with high voltage circuits, and they're putting a safety cover on there so that people who don't know what they're doing don't accidentally touch high voltage. As you can see on that little cable, it says 110 volts. That's going to be your high voltage stuff. So I'm guessing this has an AC powered heated bed. It doesn't move a whole lot. It's not like a bed slinger where you've got a lot of motion, and a lot of printers are using AC powered heated beds now. I don't love that idea. I like low powered electronics whenever possible, but just be careful. You got some high voltage there. Also high voltage there because you know, there's the power supply and it's taking wall voltage. Back here you've got your two exhaust fans. Here's the sheet metal cover. Those are your perforated mesh holes. And then I'll give you a little close-up of this PCB because that's cool stuff. Looks like a little MCU. Now curiously, these Z, Z1, Z2, Y, X, those little spots are not populated. Maybe they changed how these things are controlled. Maybe these little motors have controllers built onto them. Maybe that'll be a topic for another video where we take a look at the motors and figure out exactly how those are working. It looks like there's some sort of encoder on there. There's this curious little metal cylinder. What I think this is a tiny little gear motor. There's one on the X and the Y motor, or you know, both sides of the Core XY motion system, those motors. I think that's a little motor that controls belt tension. You know, on other printers it's like a completely manual process. On some of them it's a semi-manual process. And this one it looks like it's fully automated, which is pretty sweet. And this is all a big plastic injection molded back piece. And just look at all these wires and cables. Like, this thing is insanely more complicated than your old Ender 3s. Down here, this is the little plug that goes to the CMS unit. This little feeder thing, it's got a little spring-loaded buffer system in here, and it can accept 4. So that's how you would get 8 or 12 or 16 colors. You just attach more CMS units into the back of the machine. Pretty cool stuff. Here's your cables. It's actually the exact same cables, or nearly the exact same cables, that you get on the Bamboo Lab AMS system. This is a Bamboo Lab buffer system. It's got a little spring-loaded buffer here as well. And they're using pretty much the same type of connectors between Creality and Bamboo Lab. I mean, these are industry standard connectors, but the fact that they're using the exact same connectors is a little fishy to me. There may have been some copy and paste going on there. And then you've got an additional blower fan blowing on those high-powered electronics. I'm guessing this is a solid-state relay, that little yellow thing. I'm not going to poke these because you definitely don't want to be poking any of this stuff with your fingers, because high voltage is bad. Maybe one of you knows what some of this stuff is and you find it interesting for some reason. Here's your chamber heater. On the left side, you can see that little white object. There's one on the left, one on the right. I believe those are thermal fuses. If you had a thermal runaway situation where those were getting too hot, it is connected to a plastic enclosure. So you definitely don't want that overheating, because when plastic gets too hot, it's not a good time. I'm guessing that's a doubly redundant system for cutting power to the chamber heater in the event that it gets too hot. Then you've got the output for your filament. When the printer poops, it comes out of this chute in the back. I don't know what those are, but there's one over here and there's one over there, and they're hooked up to these motors. Over here you can see a couple of the metal to metal joints that help hold the frame together. Looks like we've got 2 bolts going into this black plastic part, and then you've got 2 more bolts. They're either just being bolted to this other metal piece, or they're going through and bolting into this black plastic piece and helping hold everything together. In any case, that looks like a very robust joint. And maybe this is a belt tensioning screw. I don't know. There's a lot going on here. This printer's absolutely crazy, and the craziness continues on the inside. It's going to take a while to figure out how all this stuff works, and I don't know if Creality is going to be open sourcing. I hope they do, because that's always fun when they do, but they're not required to. But I would like to see what's going on with this. Getting those CAD models and being able to do your own mods and have people in the community figure out how all this stuff works and reverse engineer their own mods. Like, that's all good fun. We didn't even get to talk about this top system that much. This CMS system can be bolted to the back of this unit, or it can be bolted to the back of the sheet metal thing on the back of the printer. There's a lot going on in this printer. I don't know if I'm going to be designing any mods for it, because it just works the way it is, and the amount of work required to develop mods for this thing is going to be substantial compared to other Creality printers in the past. Well, let's just look at one more thing. We've got down here some little leveling knobs. We've got this silicone heater on the bottom, and I imagine there's some sort of thermal runaway fuse on there. I don't see it, but I would hope they have something like that because it's an AC heated bed and you don't want that getting too hot. In the previous video, I was trying to show you how thick the aluminum sheet is, because it is thicker than any of the other Creality printers I've been messing with, but I can't really measure it. But it's like a machined aluminum plate, so it's going to be pretty good. Also, I press fit some magnets into the parts that I printed on this machine, and they slid right in there. That's a nice solid fit. So as far as I can tell, this thing is pretty dimensionally accurate. If it wasn't good, then it probably wouldn't fit very well. And if you want to look at the print quality, here, take a close look at it. I think it's very good. These are pretty small models, and those layer lines are stacked up quite nicely. Here's a close-up of the benchy that I printed, the multicolor benchy. And those layer lines are stacked up real nice. And there's no seam between the different colors. So after it changes colors and starts printing again, it picks up right where it left off, and there's no like offset or anything weird going on. A lot of people like to measure this back part of the benchy. I'm guessing it's supposed to be 12 millimeters. I'm not sure. Then I'll measure the smokestack up here. Yeah, I don't know if that's like measuring up to what it's supposed to be, but as far as I can tell, these prints are pretty good. Here's a purge block. We'll just look at the bottom of it to get kind of get an idea of first layer quality. Just look at the brim. It's real nice. One last thing I didn't note in my initial review of this is this table that I have is a little wobbly. I did have a desk sent over to me by FlexiSpot, which would be a lot better than this table. This is like an older table that I built myself, and it's a little wobbly. So I set the desk, it's a sit-stand desk, so I set it down on top of this metal tube frame. This is a steel frame, and that helps keep the table from rocking around. So you might need to reinforce your tables a little bit for this big printer. I mean, there's only so much detail we can go into in the 30 or so minutes that this video is going to be. So hopefully you learned a little bit about this printer and took a look at the inside. I mean, in terms of quality, build quality inside of here, everything looks very well built. It's just a little too complex for my liking, but I guess it'll be fine if it just keeps working. Any electrical engineering nerds out there know what that is? Take a look at some of those chips, people. I expect a full report on my desk tomorrow morning from you electrical people. Anyways, I hope that answers some questions that you had about this Creality K2 Plus. It's a very complex machine, and I hope everything in there just works because I'm not going to be able to fix it very easily if something breaks. Fortunately, I haven't had any issues with it so far, and we'll just keep running it and testing it and see how it goes. And make sure to subscribe. I know a lot of you aren't subscribed. You got to subscribe to the channel. It's very important.